So I wanted to quickly recap where we are and what we've done so far in Chapter 6. 6.1 was a whole bunch of definitions and then some practice with adding like terms, subtracting functions, subtracting polynomials, a little practice with substitution and some graphing. 6.2 was multiplying, lots of multiplying, which you might have heard mentioned as FOIL. That's not technically correct because FOIL is really just a way to memorize doing it correctly for a binomial times a binomial, but the principle is the same, which is that you're multiplying, right? So you're going to multiply a monomial times a binomial and so on. I will try to be good and not refer to it as FOIL because of course it isn't. FOIL is just a way to remember it. All right, so we practiced lots and lots of multiplication. And now we're sitting here in 6.3. Now 6.3 is where we are going to start factoring. Now what is factoring? You've done it before probably in a class. It means you're going to reverse the multiplication process. So, and I have it in here, this little example. So when we go this direction from the x squared plus 3x plus 5 into the x squared plus 8x plus 15 ultimately, that's FOIL, yes, because first outers, inners last, but you're multiplying, you're distributing that x, and then you're distributing that 3, right? Multiplying, distributing, whatever you want to call it. Okay, and if you have heard of it as FOIL, you know, it's not technically accurate, I know, but it's getting to the right idea, right? Which is that you're multiplying in a very particular way. Now, as we go backwards, you can see going from the x squared plus 8x plus 15 back to what these parentheses things must be. That's where the fun begins because you're going in reverse. And that means it's going to be more difficult. That's called factoring. So we factor a polynomial by writing it as a product. It's a multiplication of two or more things. And each of those things that you multiply is called a factor. So in this case, for example, x plus 3 and x plus 5 are the factors. Now, that's what this box says, by the way, just exactly what I just wrote. That when you multiply, that's multiplying, distributing, FOIL, and then when you go backwards, that's factoring. Now I have a little example in here. Let me throw this one up. So I have x plus p times x plus q. Now we all know, hopefully, that that's x squared plus qx, there's your outers, plus px plus pq. And then we could combine like terms. These two in the middle that I've underlined, they're both with plain x. Remember, p and q are numbers. They're constants. So it could be like 17 or 21 or whatever. Okay, so what would happen for that middle term is that it would become q plus p or p plus q. You'd be able to add them. Okay. All right, and that means a very important lesson. Now keep in mind that this is only true for when a is equal to 1 in a quadratic. In other words, it's only true for when it is, x squared plus bx plus c. Do you see how you don't see a number in front of the x squared? That's a sign, right? That's a sign that it is one of these. Okay. Now when that is the case, the factoring will work out so that the middle term, the one that's the coefficient of x, is going to be p plus q together. You're going to be able to add them. And the last term is p and q times each other. Okay? And that's what's kind of written in this box here. But again, this only works if it's x squared. Some students get lost when we start having like 7x squared. Yeah, you get lost because you keep trying to apply this rule. But this rule only works if it's plain x squared. Everybody sees it? Okay, so let's practice. And again, I'm sorry so much of this is typed up, but I lost a video. So, all right, so let's look here. If b is positive, b being that middle term, right, thing that's multiplied by the x, and honestly, this is also c is positive for these first ones. So I should honestly put in here positive constant c, because we'll deal with negative constants later. At the bottom of the page. Right, so C positive, see it right there? So when C is positive, this is going to work this way. What's going to happen is you're going to need two positive numbers. In other words, you're going to end up with factors where it's going to be a plus and then another plus. Right, x plus something, like in this example. Let's do this one. I'm sorry, this is already written up. So what you need, here, I'll make it go away. There, it's like you never saw it. You need two numbers that multiply to 12 but add up to 7. So what I did here was I figured out the factors of 12. I said, and it really helps to start with 1 and kind of work your way up. I mean, especially if you're not confident with factoring, So of course with these ones you might just know it off the top of your head, and that's fine. But this is how to do it if you don't know it off the top of your head. You start with 1, go, okay, 1 and 12. 1 times 12 would add up to 13. 2 and 6 would add up to 8, right? Because 2 times 6 makes 12. 3 and 4 would add up to 7. There it is. It's 3 and 4. Okay? So you figure out the correct one. And then you go over here and say, okay, well that means that it's x plus 3, x plus 4. Or you could say x plus 4, x plus 3. The order there does not matter because everything was positive. So it doesn't make any difference what order you put it in. Okay? So you can say it either that way or that way. They're both correct. All right? Now, what if B is positive, or excuse me, C is positive, but B is negative? Then we want to find negative integers whose product makes that. Okay, and this is where my video got eaten before, so let's see what I can do here. All right, I need two numbers that multiply to positive 20, but they're going to add up to negative 9. Okay, so let's see what I can do here. I could do 1 and 20. That would make 21. Or I could do 2 and 10. That would make 12. Oh, I'm sorry, these both have to be negative. This is only going to make positive. I need negative numbers. Sorry, negative 21. I'm sorry about that. Negative 2 and negative 10 would multiply to positive 20 because they're both negative, but they'd add up to negative 12. Let's go negative 3 and, nope, nothing, because 3 times, how about negative 4 times negative 5? That makes negative 9. There it is. Okay, and I realize that many of you, because these problems are so simple, you could do this one without even looking at it. You just kind of go in your head like, okay, what times itself, or what times what will make 20 but will add up to negative 9. So that's okay if you're that good at it. You can just write it. That's fine. That's not the end of the world. But if you're struggling, or if this is trickier for you, then write down all the steps and figure it out. And by the way, the technique I'm teaching you here is going to actually help with some harder problems. So I'm not teaching it to you for nothing, I swear. All right, now what if they're harder? Ooh, hold on. Okay, you know what I think I'm going to do? I think I'm going to do each of these separately just because I want to be able to use this little table format I've got going on here. So let me see what I can do. Oopsie. Control. Okay, so I want x squared minus 6x minus 16. And we all know this is not anything that I had written before, so that's gone, and this is gone, and we'll deal with that in a minute. Okay. Now the interesting thing is that they have different signs, and c is negative. See? Okay. So we need to figure out what numbers multiply to negative 16, but they add up to negative 6. Okay. Well, this is going to be a little bit more work here. All right, so what are some numbers that multiply to negative 16? Okay, so negative 1, positive 16. That would up to 15. Or positive 1, negative 16. That would add up to negative 15. Hopefully you noticed a pattern there. Negative 2, positive 8. That would make 6. Oh, we're getting close. Positive 2, negative 8. There it is. That would make negative 6 if you added it up. And then, by the way, 4 and negative 4 would go as well, or negative 4, positive 4, doesn't matter because that would make 0. Okay, so here it is right here. So these other ones I need to unhighlight. Hold on. Okay, so this one right here, and honestly, once you find it, you can stop. You don't have to keep going to the 4, negative 4 thing. All right, so that means that I need to write this as x plus 2, x plus 2, x minus 8. Or you could say x minus 8, x plus 2. The order, remember, does not matter for those two big parentheses as long as they're both there. Now you can't flip the sign. You can't make it x minus 2x plus 8. That would add up to positive 6. So you can't flip the signs, but you can flip the order of the parentheses. So if you want your plus 2 in front or your plus 2 in back, that's fine. Let me merge that. All right, so now we get to do it all over again, but for the other one. Hold on, let me make the font on this a little bit smaller. Hold on. There we go. And now I've got a second one. All right, so this is going to be plus 2x minus 24, I think it was. Okay, and we'll figure out what those are in a minute. We'll make this go away. We'll figure out the answers. All right, so I need numbers that multiply to negative 24, but they're going to add up to positive 2. All right, so let's highlight all of this. Okay, so it could be negative 1, positive 24. That would add up to 23. Negative 1, or excuse me, positive 1, negative 24. That would make negative 23. And hopefully you're realizing you actually don't really have to check both of these, because once you know that the one is positive 23, then you know the other one has to be negative 23, and neither one of them is useful for you. Then you could try negative 2 and positive 12. You're going to get 10. No good to you. Then you have 2 and negative 12. That would get you negative 10. See? So if you check one, you've kind of checked the other. Then let's see what we got. 3. 3 goes into 24. I'll start with the negatives. Negative 3, comma, 8. That makes 5. 3, comma, negative 8. That would make negative 5, so that's no good. How about 4 and 6? Negative 4, positive 6. There it is. That makes 2. So you keep going until you find the one that works. All right, we found the one that works. It's negative 4, positive 6. I didn't bother checking positive 4, negative 6 because I don't need to. I know what works. So this is going to be x minus 4, x plus 6. Or again, you could do reverse. You could say x plus 6, x minus 4. You can't reverse the signs, but you can reverse which parentheses comes first. Okay, let's try to get the next one done. So we're actually going to do an example. Now this one's a little bit harder because it has the y's in there. So you have x squared minus 3xy minus, oh, what was that? 28, minus 28y squared. Now you're thinking, y's, how's that going to work? Well, very carefully. That's how it's going to work. Hold on. All right. Sorry, I paused, but let me bring this in. So we need the numbers to multiply to negative 28, and we're going to need them to add up to negative 3. So you start like 1 and negative 28. That's going to make negative 27. And if you want negative 1, positive 28, that's going to make positive 27, which isn't useful to you. Then you want 2 and negative 14. That's going to make negative 12. Negative 2, positive 14, that makes 12. Again, you don't really have to do both of those because once you know one doesn't work, you know the other doesn't work either. Negative 4, positive 4, sorry, positive 4, negative 7. There it is. That makes negative 3. We can stop right there. You can say, okay, this is going to be x plus 4, y, x minus 7y. That way you'll have y squared in the back, which is what you want. You want those last two terms to multiply to 28y squared. 4 times negative 7 makes negative 28. Y times y makes y squared. And that's how you're going to do it. And as always, you could also rewrite it with this one in back and the other one in front. That's fine. But other than that, you can't do any other changes. Now let's move on to the last concept, which is prime polynomials. Now remember, a prime number is a number that can only be written as 1 times that number. So for example, 13 is prime. It's only 1 times 13. That's it. It can only be written, factored. It is factoring. Remember, prime factorization used to make the trees. So it can only be factored as 1 times that number. So you have the factors. So a prime polynomial is the same thing. It doesn't break down into 2 parentheses. It can only be written as 1 times itself. So let me give you this example. We want to be able to multiply to 15. So what are the options? 1 and 15, that would add up to 16. Or 3 and 5, that would add up to 8. None of them work, right? So since none of them work, this one is prime. Right? It does not factor. It's not factorable. Okay? These are the only combos you can possibly use to make 15, and neither one of them makes 7. All right, we're done with that. I'll meet you back here for GCF factoring. That's the start of the next topic.